So we're going to talk about scale drawings and scale models. So y'all write about being a ratio, model, and actual. So we're going to look at that. So some vocabulary. A scale drawing is a drawing that is similar, but either larger or smaller than the actual object. So similar, we're still talking about similar figures, okay? A scale model is used to represent something that is too large or too small for an actual size model. All right, so what is a scale? So, for example, you probably see this in social studies, maps, you look at maps, color maps. You'll see a scale, so it's on a map, and its intervals used to represent the ratio of distance on the map to the actual distance. So that would be a scale drawing, right? Yes.
That one says like every inch is like
Yes, absolutely. That's exactly what it is. All right. Scale factor is a scale written as a ratio in simplest form. We're actually going to spend 2 days next week on that. I think that's Monday and Tuesday. We're going to talk more about scale factor. Actually, Tuesday and Wednesday. Monday's our dismissal. Talk more about scale factor, and then that will. You have a project coming up, and so that we'll look at scale drawings and scale factor. There's some more figures. All right. So a map is an example of a scale model or scale drawing. Scale drawing. Scale drawings and scale models are used to represent objects that are too large or too small to be drawn or built to actual size. The scale gives the ratio that compares the scale drawing or model to the real object. The measurements are proportional. So we will continue set up proportions to determine actual size, the model size, and to get that scale. So if we look at example 1, we have a model of a tree is made using the scale. 1 inch equals 10 feet, so similar to what we always saying. What is the height of the actual tree if the height of the model is 4 inches? So 1 inch represents 10 feet, can be written as a ratio. And look how they set this up. Okay, we have the model over the actual. And so inches and feet, inches would represent the model, right? And then actual is 10 feet. So they write 1 inch to 10 feet as your ratio equals, and 4 inches is going to represent our model, right? The model is, and then look at your units, inches with inches. Okay, so this is a question mark. So is there any relationship that we see that we can do? We can go what? Between the fractions. We can also go within. Okay, either way, you'll get the correct answer. Okay, so if we go between 1 times what is 4? Good, so 10 times 4 is 40. Good, so that would give us 40 feet. If we went within the fraction, 10, what do we do to 10 to get, actually we would have to go down, right? Let's change our arrow there. So what do we do to 1 to get to 10? Add Absolutely, times 10, and so we would also do it to the other side, and we see we still get 40. 4 times 10 is 40. Are we good with that?
We always have to do it like
If you have, this is one way, so if you have a way that you like better than that, that's fine. Okay, this is how I'll show it, okay? All right, so with your table, I want you to do the you try number 1, example 2, and that'll be good for you. Okay, so I'll give you a few minutes and then we'll have some volunteers share. I'm gonna read the problem. On a map, Dallas is 2.5 centimeters from rock wall. The map scale is 1 centimeter equals 20 miles. How many miles are between Dallas and rock wall? Show us what you did. Good. Good, so 50 miles. Give her one big clap. 1, 2, 3. Questions? Clarify anything for that one? All right, do we have a volunteer, for example, number 2, Nikhil? We have a scale drawing of Sonia's room is shown. What are the actual dimensions of Sonia's room if 1 inch equals 20 feet? Do both. Good. 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 And then 2 times 20. Good. Answer choice C. So her actual room is 40 by 60 feet. I wonder what room that is. That's pretty big. All right, let's give them one big clap. 1, 2, 3. Questions? Okay, so number 3, it says the model of a building is 24 inches tall. The actual building is 96 feet tall. What scale is being used? And so a format, so what would that look like if they're asking for scale? Okay, it does need to be in simplest. And when we talked about scale, what does it look like? They want the scale being used. Is this scale? Yes. Let's look at above. The scale is, so our answer needs to look like that, okay? What else do you notice about the scale? Do you notice anything? That the model is always what? To 1. Good. So that's going to help us set up our proportion. So the model of the building is 24 inches. The actual building is 96 feet. What scale is being used? So we want to know how many inches. Okay, 1 inch represents how many feet. So our proportion, we need another number. What number do we know for sure has to be in our scale?
1 inch equals 1.
Good. 1 inch has to represent something. So how do you know it, your answer?
I just divided 96 by 24.
Good. You could do that. Yeah. Or you could do what? 24 and divide. It's the same thing he said, right? 96 divided by 24 is what? 4. 4. Yeah. And then so our final answer, because it needs to be look like scale, 1 inch represents 4 feet. This is your scale. That's the scale for the building. So for every inch on the paper represents 4 feet. Are we good with that? All right. Y'all do, you try number 2, and then we'll have a volunteer come share.
I don't think I was recording. Oops. Good. So we got C. One big clap. 1, 2, 3. Questions on 12.5 inches for the model. All right. So I'm going to give you this, and you're going to complete odds only, and then we will check as a class. All right. Let's look at numbers 1, 2, and 3. Did y'all get 16 inches for number 1?
Oh.
Questions? Okay, number 3, 77.1 centimeters. We're good with that? Okay. And number 5, 1 inch equals 9 miles. Are we good with that? Awesome. Okay, go ahead and turn it over to the back. And then number 7, the value of x, 18.6 repeating. Let's make sure we have that repeating symbol there. And number 9. Side YZ is 29.25 inches. Do we need to look at that one? Yes. Okay. So we have triangle ABC is similar to triangle XYZ. Find the measure of side YZ. Where's YZ? Right here. So YZ corresponds to BC. Okay. So we have 6.5 represents X. Okay. And then we can use any side line they chose. Just looking at, it doesn't matter which one you chose. Okay. But if we're going to use XY. Okay, so XY corresponds to AB right here. Okay. Okay, so 6.5 represents X, so 4 corresponds with 18. Are we good with that? So y'all probably gotta make sure you're using that congruent statement. It gives you the answers of corresponding sides. So we're good now. Okay, let's look at our last one. To determine the perimeter, 96.25. Did you do this one? Yes. Okay. The 2 rectangles are similar. Find the perimeter of the larger one. So we have 3, right? Y'all don't have a link right here, do y'all? Okay, so that's what we're trying to find. So 3 represents X, and 8 centimeters represents what? 35. Okay, and then we need to find that relationship there to get 13 and 1/8 or 13.125. And how can we do that? What can we do? What do you get?
3.75.
So 8 times 3.75. How did you get 3.75? 8 divided by 3. We're good with that? Okay. And then 35 times 3.75. And did you get 13.125? Okay. So this side length is 13.125. Well, and we want the perimeter, so we need to add up all the sides. If this side is 35, 35 plus 35 is 70, right? And then 70 plus those 2 sides. Okay, and that will give us the perimeter. Perimeter is adding up your side lengths on any figure, okay? Any other questions? All right, so all the evens are homework. Are we good with that? Evens. Do tomorrow, but actually Monday. Okay. Do you on Monday, we'll look at it.